we are back at AP Review. We are now doing 2016 AB Free Response 2. For t values greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by this equation. The particle is at position x equals 2 when t equals 4, so that's x of 4 equals 2. Part A, at time t equals 4, is the particle speeding up or slowing down? So this goes back to those questions where we have to remember what the colloquialism speeding up and slowing down mean, right? So speeding up means that velocity and acceleration have the same sign. It doesn't matter what sign, just the same sign. So speeding up could be driving forward and hitting the gas pedal, which would be accelerating. So you're driving forward, that's velocity positive, and you're hitting the gas pedal, so acceleration is positive, and you're speeding up. Speeding up could also be plummeting out of a plane without a chute. Your velocity is negative, your acceleration due to gravity is negative, and you are absolutely speeding up as you plummet. Slowing down means acceleration and velocity have opposite signs. So, in order to do part A, I need v of 4, and I need v prime of 4, which is the same as acceleration, right? So it's a calculator question, right? I put v of t in as my y1, so while the AP doesn't care, you should make sure that you know what you put things in your calculator as. I put it in as y1. So in order to find v of 4, all I have to do in my calculator, right? There are a couple different ways to do it, but the easiest way to do it is to graph it in your calculator. This is my crazy, crazy v graph, right? And if I hit trace and 4, that'll be when t is 4. So I graph it in my calculator, I hit trace and then 4 for the x and hit enter, and I get that this is 2.978 or 9, depending on if you round or truncate, which is positive, right? If I then want v prime of 4, the way I'm going to do this is I'm going to do one of two options. You can either do n derive, which is math 8, or since you're already graphed, you go to second calc and you could pick dy dx, right? So I go to second calc, I pick dy dx, and I'm going to do it when x is 4. So I hit dy dx and hit enter, I hit 4, and it's going to give me that dy dx at that moment. It is a negative 1.164, which is less than 0. So because they have opposite signs, I am slowing down, right? So the answer is slowing down because v of 4 and a of 4 have opposite signs, right? So the relationship is that they have opposite signs. Okay, cool. Part B, sorry. Find all times t in the interval from 0 to 3 when the particle changes direction, justify your answer. Okay, so again, this is a calculator section, right? So you need to lean on this calculator and make it do all the work. You're just doing the thinking. The calculator's doing all of the like grunt, brute force kind of stuff. So we need to think about what they're asking us, right? They're asking us about when we change direction, right? What it means to change direction, the definition of that is that v of t changes sign, right? V of t changes sign, right? But then we need to link that to what we're going to be able to see in this problem. So what that means is that our given graph, the one that's in the calculator, right, crosses the x-axis. That's what we're looking for. We're looking for when this thing crosses the x-axis. So once I know that, I look at my window. My window's crazy, but they said from 0 to 3. So I'm going to go to window, and I'm going to specifically set my x's to go from 0 to 3, right? So I'm going to graph, and I need to count how many times it crosses the axis. So it starts above the axis, still above, crosses, and that's it. It just crosses that one time, right? So it crosses once, and then I need to find what that, so I want to know when I cross the x-axis, so I graph it, right? And it looks like this, and then I'm going to second calc 0, right? So I'm going to second calc 0, so I do second calc 0, right? I scroll over towards that 0. I want to stay to the left of it, which is not a problem right now because we're not scrolling very fast. All right. I'm to the left of it, and I know I've crossed to the right of it when I cross the axis, so my sign on the y changes, and then I guess, and I get that my t, even though it's x in the calculator, I know it's t, is approximately 2.707. Notice it wasn't just that I had a 0, it's that I had a 0 that crossed the axis, right? So they said, find all times when the particle changes direction, and then justify your answer. So now my justification is that v of t is greater than 0 before t equals 2.707, and v of t is less than 0 after t equals 2.707. So it crosses the x-axis, right? So our justification is that, or the other way you could say it is you could say v of t changes from positive to negative, right? So changes from positive to negative, right? You could say positive to negative. All right, cool. Part C. Find the position of the particle at time t equals 0. So this is a first fundamental theorem of calculus problem. So for part C, we know that v of t is the same as x prime, right? So v of t is the same as x prime of t. So I know x of 4, and I want x of 0. So if I were to integrate from 0 to 4 of x prime of t dt, by the first fundamental theorem of calculus, when I integrate x prime, I just get x. So I get x of 4 minus x of 0. Well, this is a thing I know. This is a thing that I can make my calculator do. And this is the thing I want. So if I move the x of 0 over and subtract the integral over, I get x of 0 equals x of 4 minus the integral from 0 to 4 of x prime of t dt, right? So I know that x of 4 is a 2 minus, and then I'm going to plug in my calculator, function integrate y1 with respect to x from 0 to 4, right? And that's going to give me my x of 0. Now, the AP doesn't want to see this. The AP wants to see this. And actually, they probably want you to do them the solid of calling this v of t because that's their notation, right? You should generally use their notation. So I'm going to go ahead and type that in my calculator, right? So I get 4, I'm sorry, it's not a 4, it's a 2, minus math 9 of vars over to y vars, pick y1, comma, with respect to x from 0 to 4. And I hit enter. And it thinks for a bit, and I get that x of 0 is approximately negative 3.815. Okay. Part D, find the total distance the particle travels from 0 to 3. Okay, so the thing about total distance is that on a non-calculator question, it's really frustrating and difficult. But on a calculator question, you just need to integrate the absolute value of velocity. So total distance, the easiest way to find total distance is to integrate speed, right? So if velocity is v of t, then this thing is called speed, right? And I'm going to integrate speed from 0 to 3. Right? And that's all I have to show. And then they don't care, but this is what it looks like in your calculator. Function integrate. You're going to go to math over to number and pick absolute value, which is abs, of your y1 with respect to x from 0 to 3. And then you're going to get an answer that you give the AP, right? So again, they don't care about this notation, but you need to know how to do it. So I'm going to hit math 9, right? I'm going to go to math over to number and pick abs, vars, y1, right? Close that out with respect to x from 0 to 3. And I hit enter. And then we just wait, because sometimes it takes a while. Still happening. That's why you're happy that your calculator's doing it. And you get 5.301. The end.